The deep waters of the Pacific Ocean off the eastern coast of Australia are legendary for deep-sea fishing adventures. These waters teem with impressive marine life, marlin, swordfish, and even sharks. But in March 2019, something extraordinary happened that would challenge our understanding of ocean predators. A local fisherman hooked what should have been a prized catch, a massive 550-pound mako shark. Yet, as he hauled his trophy aboard, he was met with a horrifying sight. All that remained was the shark's severed head. Something in those depths had devoured the rest of this apex predator. The images quickly spread across the internet, showing the mako shark's remains just ahead, cleanly severed as if something had taken a single catastrophic bite. Marine biologists were stunned. What creature possesses the jaw, strength, and sheer size to bite through a mature mako shark like this? The speculation began immediately. What monster lurks beneath these waters? This incident might seem isolated, but it's part of a disturbing pattern that scientists have been tracking off Australia's coast for nearly 2 decades. In 2003, Australia's premier scientific organization, CSIRO, launched a satellite tagging program to study great white shark migration patterns. Among their subjects was a specimen they designated Shark Alpha, a formidable 9 to 10-foot great white. Hardly a vulnerable creature in the ocean hierarchy. 2 months into the study, researchers noticed something alarming. The tag data showed Shark Alpha being chased down the continental shelf to a depth of approximately 2,000 feet. Then, incredibly, the data suggested the shark had been consumed whole. The tag continued transmitting from inside whatever had eaten the shark, revealing a constant internal temperature of around 72 degrees Fahrenheit, regardless of the depth. This temperature bubble remained stable, confirming the tag was inside a living creature's digestive system. The implications were staggering. What marine animal could possibly hunt and consume a great white shark? The proportions required for such a predator would be colossal, pushing the boundaries of what scientists believe possible in our modern oceans. But the evidence didn't stop there. In 2023, a disturbing event occurred along Western Australia's coastline when numerous pilot whales beached themselves in an unusual formation. Despite rescue efforts to guide them back to deeper water, the whales repeatedly returned to shore, seemingly desperate to avoid something in the ocean. Whale pods typically rely on strength in numbers when faced with predators like great whites. The fact that these intelligent creatures chose certain death on land rather than return to the water suggests they were fleeing something truly terrifying. Could it have been a creature approximately 65 feet long, something previously undocumented that inspires such primal fear, even in large marine mammals? These incidents paint a troubling picture. Could they all be connected? Is it possible that a single species of mega-predator is responsible for biting a 550-pound mako shark in half, swallowing a great white shark whole, terrorizing a pod of whales to the point of mass suicide? Marine biologists remind us that we've mapped only about 20% of our oceans and have directly observed merely 1 to 2% of what lies beneath the surface. The deep ocean remains Earth's final frontier, a vast, unexplored realm where ancient creatures might still exist, hidden from human discovery. The megalodon theory has naturally emerged in scientific circles. This prehistoric shark species, which went extinct approximately 3.6 million years ago, could grow to 60 feet in length, with a bite force estimated at over 40,000 pounds. Its massive jaws could easily account for the damage observed in these cases. But could a species believed extinct for millions of years somehow have survived? It's not unprecedented. The coelacanth, a prehistoric fish thought extinct for 65 million years, was discovered very much alive in 1938. The vast, largely unexplored oceanic trenches could potentially harbor remnant populations of ancient species. Other theories point to giant squid or colossal octopus species. We know the giant squid can reach lengths of 43 feet and possesses tremendous strength. However, their hunting patterns and physiology don't align with the evidence from these incidents. The stable internal temperature recorded by the shark tag suggests a warm-blooded predator, eliminating most invertebrates as suspects. Some researchers have proposed unusually large orcas as potential culprits. These highly intelligent predators have been documented killing great whites, specifically to eat their nutrient-rich livers. Yet, even the largest orca would struggle to swallow a 10-foot shark whole, and their known populations are well documented and tracked. The uncomfortable truth is that science currently has no definitive answer. The puzzle pieces don't fit any known species. What makes these Australian waters different? The region sits at the convergence point of multiple ocean currents, creating nutrient-rich environments that support diverse ecosystems. The continental shelf drops dramatically offshore, quickly reaching depths where human exploration becomes challenging. These abyssal zones could harbor species that rarely venture into shallower waters where they might be observed. Climate change and shifting ocean temperatures may also be driving deep-sea creatures into new territories, bringing them into conflict with species they wouldn't normally encounter. As ocean acidification and warming continue altering marine ecosystems, we may witness more unusual predatory behaviors and encounters. For now, fishermen in the region proceed with caution. Local authorities have increased monitoring efforts, deploying additional acoustic receivers and satellite tracking systems to detect unusual predatory activity. Some fishing charters have modified their operations, avoiding certain deep water zones during specific seasons. The search for answers continues. DNA analysis of bite patterns, advanced sonar mapping of the continental shelf, and autonomous deep-sea drones may eventually provide clues to this oceanic mystery. Until then, the possibility remains that somewhere in the dark waters off Australia's coast, an undiscovered apex predator continues to hunt, a true sea monster that defies scientific classification and reminds us that even in our modern world, some mysteries remain unsolved. The ocean, it seems, still has secrets to reveal.